Welcome to this Sahara 4 exercise. In this exercise, we will use the mapping tool. For that, we will open our Sahara project, and once here, we will go to Tools, Mapping, and here we have the mapping tool window. So, the process called mapping consists of obtaining the values of the nodes of a grid by means of a calculation algorithm. So we will have an x and y position from a certain value. The input can come from different sources. Here we can see if we go to the mapping data. Here are the different sources that we can select to map. In this case, we will use petrophysical data because we will plot porosity across the project in different layers. So the idea is that you have an x and y position that is defined by the coordinates of a well in a certain layer. It will change obviously if you have trajectories. And a value, in this case a petrophysical data value, that will be plotted in all these x and y coordinates. So the idea is that with everything together, you will have a representation of a surface that is associated with your porosity. So there are plenty of different algorithms that you can use when mapping. Here you can see them, their name. Each one will have its own advantages and disadvantages that should be considered when selecting them. You can learn more about them in the user guide, in the appendix of the user guide. For now, we will use Shepherd in all the mappings that we will do. Is the most common one. Here you can use this option to select which wells you will use for the plotting. In this case, we will use all the wells available because we have valid petrophysical data in all of them. We have checked it in a previous exercise. We will select layers. In this case, we will plot only the layer 17 in this first example. Then we have to look for the mapping data. As we discussed, we will plot porosity that is coming from the petrophysical data. Here we have the different petrophysical data that has been imported or created, in this case, of pore volume, that is a calculated value. So porosity at the layer level. And here we have a first way to check that everything is okay. We will see that we have uh, the whole project plotted here, and we see which is the value associated that is going to be mapped for this variable porosity. Something that happens and is quite common, especially when you are plotting tops, is that you will select everything like this, and you will see your wells without any value in them, even if you know that you have a top associated. The cause of this is that you don't have any datum loaded in the project, which means that there is no way to convert from the MD in which the top and bases have been imported most commonly into the TBD sub C in a common reference point, because you need to import the datum of each well. That's a very common mistake and it happens quite often. So if you want to create a structural map, a map of tops, and you have this problem, it's because you are missing your datum in each well, which is defined in edit objects here, in edit well data, and there you can define the datum for each well. Well, without any further ado, we will keep checking the options here. We have the correct layer selected. We see that everything is plotted correctly. We have selected the variable as well, which is the porosity at the layer level. And here in calculated area, we will define the total area that will be calculated that the map will cover. For example, if we use data area, we will define a rectangle that circumscribes the data plus a margin that will be defined by the radius of expansion. So we can map it here just to see how it works. Here we can increase this radius of expansion. Maybe this is too little. Yeah, let's use a bigger value. And here we see that this definition, this rectangle has been expanded. So if we go back to 0, we can see that here the limits of the rectangle are here in this position. Now if I go here, we can see that the rectangle ends in the last value, this one, 20.8, and is going to use these other values and this one to define the other limit of that rectangle. Then we have, for example, all project that is going to consider the whole project expanded by the maximum radius, and here we can see that we have the the most extended map available. Here with polygon, we can define a polygon where we will map the the points inside that polygon, and here only this area has been selected. We can define if we want to include or define as zero the vertex, and here we can see that the vertex, the limit points of the polygon are defined as zero. In this previous case, they were not included, so we were mapping up to the vertex, and then the value here is null. It doesn't have any value for the vertex. Here we have other options, convex hull, for example. In this case, convex hull is the option of automatically generating a polygon around the data. The polygon is obviously is going to be convex, so you will have a resulting polygon that is going to be equivalent to placing a rubber band around your data, and it's going to be enlarged by the value of expansion. The next option available is the opposite one, concave hull. In this case, you always need to define an expansion radius. Here we will plot it for the example with this expansion radius. Basically, this algorithm is going to generate a concave polygon around the data. The result is equivalent to covering the surface with circles of radius equal to the expansion radius. This method will allow you to do the calculation of non-connected region, for example, when more than one data set is available, and is in general is less common to use it, but it's available. Here we can use another map, another one. We have imported some maps here before. For example, we can use the top map as a base for the limits of this map. So now you can see that we have covered the same shape for this layer that we had for the top map. If I use a different one, let's see if it has a different here. So now we are mapping the porosity only the places that we have gross thickness. If I use net thickness, we will only plot porosity in the places that we have defined the net thickness with the other map that has been imported manually. So let's see if we have any other, and the last one, line. Here we can use a line as a way to limit the map position. So here we can use the borders that, if you remember, we have imported. Let's hide this one, default. We have imported lines before here, which define the limits of them of this layer. So we can use the same lines to define the limit of our map. So now for our mapping, we will consider the map calculation area. We will copy the shape of the net thickness map that has been imported, and we are now using the algorithm shepherd. So now we have our porosity map that will represent the position defined by the wells in this layer, that is mapping as a surface all the porosity values that have been imported as petrophysical data, copying the shape of the net thickness map that has been imported before. So here we have other options that we can explore. For example, we can include the faults of that we have faults here. We can include the faults of this layer for them not to be plotted. So if we include calculate here, we see that the position where the fault is as loaded as a line is going to be excluded from the mapping here. We can also use control points. The control points will allow us to include points that are not coming from the wells, that have a specific x and y in a specific x and y position. You can, for example, say, okay, I know my porosity here in this position is 25, just as an example, and it will allow us to include other points manually that are not coming from the wells necessarily. So in this case, we will not use them. The preserve previous option will allow us to all the different calculations that we did will be on top of the last one. So we will always include the previous calculations in the map. This is useful especially if you are, for example, plotting with the mapping with polygons. So if you want to, for example, have this area plotted but not this one, and you want to also plot this one, you can use this option to start selecting polygons and adding them up all together in a single mapping session. Here we can select the algorithm and the different options associated to it. Um, Here we can include the references of our map in the mapping tool. So here we can see the minimum value with this gamma is 11.3 and the maximum is 26. Here we can select if we want to see the map as isolines or as a grid. In this case, I want to preserve it as grid. We can also see the borders of the grid here. Here, if we select isolines, we will have other options. For example, filling the isolines, and also seeing or not the borders. We can also add labels, and the step of the isolines can also be defined. But we will preserve it as grid here. We can select which gamma we want to use here to plot this map. We can include our borders here if we want to see them. I will uncheck this and calculate again. So here we can see what I was talking about before, that with this option, when selecting faults, I will cut the map by using the surfaces that I defined previously. I will, however, uncheck this because I want to have the whole map. Um, Here you can also use these options to include the well names if you want to see them, and the surveys in the case that you have any, but in this case we don't have any trajectory or survey loaded, so it's not going to show us anything in this case. So other things to consider, we can select multiple layers here. I will do the final mapping, so I will select all of them. Remember that here that you can use shift and control to select several layers. For example, by using control I can select them like this. If I use shift, I will select from the first one to the last one and select them all. Yeah, that doesn't matter. And here we see that it's not changing the layer selected. I will try again. I was forgetting to select them actually. And here we can use we have now selected all the different layers. As we selected more than one layer, we won't see the values of a specific layer because we have selected plenty of them, so there is no way to show all this information in a single plot. But here we will click on calculate, and now we have plotted. Here we have a warning that we have already a previous porosity map on layers 17, but yes, we will overwrite it. We want to plot all of them with the same options. And now we will have this small report here that will tell us that we have 53 maps calculated, and we have a total of 0 inconsistencies, so everything was fine. And now we have all the maps, all the porosity maps with the options that we defined previously. Okay, so that should be everything for now. We have all of them saved. In the case that in this case, as I use calculating several layers, the maps are automatically saved. In the case that they weren't, you can use the option here save to save each map. We can use this button here to initialize the window and reset the map that is being plotted. Here we can load an external map. We can use this option to see more information about the loaded map or the map that is being plotted here. These options here are to zoom and unzoom this window. For example, if I zoom here and I press here, it will unzoom it to allow us to see all the different values. Here we can copy to the clipboard this map here. Here we can create polygons. We can do this, select these polygons, and use these options here to delete everything inside the polygon, the selected polygon. For example, if I use this one here and I want to delete everything inside the polygon, this area of the map will be deleted. If I use this other option, delete outside the polygon, everything that is not inside this polygon will be deleted. There is a specific tutorial about polygons that is already loaded, that you can see in another exercise, in another tutorial. And here we add the control points that we discussed previously. I'm going to erase that polygon here, here. So now that is not on the way. So here we can create the control points that we discussed previously. If I click in any, let's say that I want to ensure that a place has 20% porosity, I will say that that's the value of the control point, and I will add it here. And now we have a value that is specifically 20 for this position, and we can add them one by one, the control points around the map. We can move the point here like this with this option. We can delete the point as well. We can use isolines as well to define the control points if we load a map as isoline. And here we can paste, if we have the points, for example, in an Excel sheet, we can use this option here to paste them from clipboard and have them all together in this X, Y, and Z table. So yeah, that will be everything for this tutorial. I hope it was useful. We will do, before leaving, we will close this one, and we will check if they will correct, if the maps were correctly stored. So for that, let's go to an example layer here, the number 8, and we will go to maps. We see here that we have the maps that we imported before are listed as in this branch, inside the map branch in the map window. Here we will add porosity that is available now. As you can see, we have porosity as another option that has become available because we have now maps inside the project that are associated to the variable porosity. And here we can see that porosity is now available to be selected. And by clicking here in this checkbox, now we have the porosity plotted in this map. Let's see. So yeah, it seems that the values are quite close one to another one. So that's why we have this strong blue value. Maybe it will be more useful to use a manual here, gamma palette, color palette. So we'll define the maximum as, for example, 30, and the minimum probably around 10. And here we have something a little bit more clear, where we can see the different values of porosity in our example layer. And here we can use them, the same concept for the different layers. Here, if we want to check as well, we are copying the net thickness map. We have the same, I will show this as grid. So we see that we are copying the same shape of the net thickness map. That was the criteria that we decided in this example for this map. But yeah, now yes, that will be everything for this tutorial. Now we have the maps that we created from the petrophysical data stored in our project. I hope it was useful, and see you in the next one. Have a good day.